In this video, I would like to bring all the t-distribution concepts, degree of freedom, the area under the curve into one example. So in this video, I will solve these three probability questions, and then I will make a separate video to do the inverse t-distribution. All right, so let's start. A job interview website reports that the average income of quality assurance engineer with 10 to 20 years of experience is $85,000. The population standard deviation is unknown. This statement is extremely important. So when sigma is unknown, this is an indication that you should use t-distribution. Why is this a t problem? The underlying statement tells you why. You don't know sigma, then you use t-distribution. I don't care how small or how big the sample is. As long as you don't know sigma, you use t-distribution. Sample size, I don't really care. The incomes follow normal distribution, and then we have in each problem, it looks like they have a different n and sample standard deviation for you, right? So they have the mu equals to $85,000, and then the standard deviation and sample size is different in each problem. Okay, so in part A, they are asking n is equals to 17, and then S sample standard deviation is equals to 8,000, and then find the probability that the average income is at least, which is no less than $86,000. Okay, so first we standardize that. So we have a t greater than or equal to, we take 86,000 minus the mean divided by s over square root of n. And then in case you don't remember the formula, that is t equals to x bar minus mu divided by s over square root of n. So let's approximate this. So we have parenthesis 86,000 minus 85,000, and then divided by, remember to close parenthesis, 8,000 over the square root of 17. And then we have, let me make sure I type everything right, 86, 85, 8,000 divided by square root of 17, so that is approximately 0.515. I keep 3 decimal places, and then you draw a little picture, and then you draw a t-curve. The 0 is right in the middle, and then we have 0.515 greater than or equal to, so this is a t-CDF from 0.515 to positive infinity, and then the degree of freedom is 17 minus 1. Okay, so let's find out the probability. Second vars t-CDF, and then we go 0.515 to positive infinity, 1 second comma 99, and then 17 minus 1, or you type 16. So the probability, how come there is an error? Oh, I type PDF, sorry. Okay, second vars t-CDF 0.515 to positive infinity, and then 17 minus 1, so we have the area 0.3068. So that is the answer to the first problem. So back to the central limit theorem, the Z procedure, we can use one command to get this probability, but unfortunately in a T procedure or T distribution problem, there is no shortcut. You have to standardize and then use t-CDF. All right, let's do the next one. The next one is at most. So in part B, we have n equals to 20, and then there is a trick. They have a sample variance, so that is s squared equals to this. That means s is equals to the square root of that. And then we have to find at most, so x bar is less than or equal to 84,200. Okay, standardize that. So we have t less than or equal to, we take the given value, subtract the mean, and then divided by s, we have to take the square root of that, and then divided by square root of n. Okay, so let's approximate this first, and then I will use the tcdf command to find the probability. Okay, parenthesis 84200 minus 85,000, close parenthesis, divided by, I have two square root of 6250, and then 30, and then divided by, make sure the division is outside of the radical, and then second x squared, that gives me another square root of sample size, which is 20, and then you close the entire parenthesis, so that is negative 1.431. All right, so negative 1.431 less than or equal to, so that is a TCDF from negative infinity to negative 1.431, and then the degree of freedom is 20 minus 1. Second was TCDF, and then from negative infinity to negative 1.431, and then the degree of freedom is 20 minus 1, so the area is 0.084 and then 3. Okay, so that is part B, and then part C is between two numbers, right? So part C, we have n equals to 10 and then s equals to that, so n is equals to 10, and then the sample standard deviation is 7,500, and then we have between, okay, I hate to pick this number up, so this is 84,550, and then x bar, and that's 86,250, 86,250. All right, we do the math right here. First, we standardize, so that is 84,550, subtract the mean, which is 85,000, divided by s. S is the square root of 62, s is given right here, divided by 7,500 over the square root of 10, and then t, and then 86,250 minus 85,000 divided by 7,500 over the square root of 10, so that is equal to, so let's go to our calculator. Okay, parenthesis 84500 minus 85,000, close parenthesis, divided by 7,500 divided by the square root of 10, and then close the parenthesis, so we have a negative 0.211, and then the other side, I don't want to retype this, so I will click second and then enter, so the previous entry pops up. I will just overwrite the first number. So on your calculator, just use the left arrow, move the cursor to 8, so now the cursor is on A, so the A is flashing, right? And then you start typing 86250, so that overrides the previous x value, right? And then you hit enter, so that is 0.527, and then the t curve is, we just use a bell curve, we have a 0 right in the middle, so negative 0.211, positive 0.527. This is the area that we are looking for, so that is a TCDF from negative 0.211 to positive 0.527. The degree of freedom is 10 minus 1. All right, so we go to second VARS and then TCDF. We do negative 0.211 to positive 0.527. The degree of freedom is 10 minus 1. Why do we need to care about the degree of freedom? The answer is, this is a t distribution, the t procedure. The degree of freedom determines the shape of the t curve. That's why the degree of freedom is so important in t distribution. So the probability is 0.2757. So the answer part C, and which is the end of this video. The example is, this is not the end of this example. So in the first 3 subproblems, I show you how to answer probability questions. And then in the next video, I will show you how to use the inverse t distribution, so inverse t, to answer percentile problem. All right, I will see you all over there. If you think my instruction is helpful, let me know in the comment section below. I would like to see your comments, and then subscribe to my channel, share the video for me. let more people get help from me. Appreciate your help as always. I see you all in the next lesson for the inverse t distribution. Signing out.